Hi there, folks. We're going to be talking about Venn diagrams today and their connections to sets. And so without further ado, we'll go ahead and get started with our first definition of what a Venn diagram is. In all Venn diagram, when you're taking a look at that, all we're looking at is just a illustration of sets, and it often uses circles to represent the sets. Now, in this case, we will stick with circles, but there are some cases where you can use different sort of shapes to represent them. But for our case, we'll deal with circles. And so looking at an example of this, what would this look like? Well, we can create two circles that actually overlap a little bit, and let's try and distinguish what each of these is dealing with. So in the first case, let's look at, we have a blue circle indicating college graduates, and then a red circle indicating people making less than $30,000 per year. So if we look at the blue circle that's outside the red circle, what does that mean? Well, inside the blue circle, we're talking college graduates. Outside the red circle, that would be the opposite of people making less than $30,000 a year. So that would be college graduates making $30,000 or more per year. Moving forward, if we look inside the red circle but outside the blue circle, what are we looking at? Well, inside that red circle means that we have people making less than 30,000 per year. But outside that blue circle means that they did not graduate from college. So did not graduate college and they're making less than 30,000 per year. And moving forward from there, we can look what's inside both the blue and red circle. What does that indicate? Well, it's a visual representation of just that's college graduates that make less than 30,000 per year. So we're having that overlap of both. Okay. And then last but certainly not least, when we look outside of both the red and blue circle, that means we're basically negating both of those sort of situations. And so that means they're not college graduates, so people that did not graduate from college, and they're making more or exactly 30,000 per year. So 30,000 or more per year. So moving forward from there, what we want to do is start to do stuff with these Venn diagrams and start to indicate certain types of representations. And so we'll look at a definition first, and we say that two sets are called disjoint sets if they have no elements in common. And so what would that look like? Well, let's try and create a Venn diagram with two disjoint sets. Well, we can use the rational numbers as our playground, I should say, for our universal set. And then we don't want any overlap between these sets. So all we do is we draw two circles with no overlap. And what that indicates is that we have no values in common. And just to hit the point home, an example of such of these in the rational numbers, integers are rational numbers, so you could do the even integers and the odd integers, and there is no overlap in those cases. So that gives you an example of something that has no elements in common. Those are two disjoint sets. Another example, if we wanted to create a Venn diagram representing a subset of a set, so that's something we've seen before. Way we could do that, we could say maybe North America is our universal set, and we could look at the United States inside of North America, and then inside the United States we could say the southeastern United States. Notice it doesn't make up all of the United States, so we have this proper subset looking right here. Okay, so it's a circle inside of a circle. That's all that we're indicating there with a subset. Now, the more commonplace sort of scenarios will be where we do have overlap. And then what we want to start talking about is the cardinality of a set. So the cardinality of a set, which we denote by this absolute value, it looks like of A, but that is, since A is a set, it's not absolute value, it's the cardinality, and that's just the number of elements in the set A. Okay, well, if we look for an example, how do we do this, and how can we actually use Venn diagrams to benefit these counting of the number of elements? Let's create a Venn diagram for the following table, where we're dealing with auto insurance claims, people that make auto insurance claims, along with the people, the gender of the person. So we have listed here in our little table, we have people that made an auto insurance claim, people that did not make an auto insurance claim, people that are male, people that are female, and then we have those numbers, 57, 42, 172, and 109. Now, when drawing our Venn diagram, most people might say, oh, we need 4 circles. Well, that's actually not the case. And I'll explain why real quick. If you take a look, as soon as we put the male circle down there, that means outside of the male circle, we're talking female for this circle. Okay? And then in a similar manner, for made an auto insurance claim being a circle, everything outside that circle will be did not make an auto insurance claim. And so you have those sorts of scenarios, and now we can start to fill in. Well, first, if we take a look, okay, we want to look for males that made an auto insurance claim, and that would be indicated by the overlap of the two circles right here. So, and that's where we should put our 57. And if we wanted to do another one, let's say we did males that did not make an auto insurance claim, so we need to be outside the made an auto insurance claim circle, but inside the male circle. And so that would be right here, and that means we put the 172 down at that position. In a similar manner, we can put down the made an auto insurance claim that are females. That would be 42 possibilities. So the 42 should go right in this circle right here, if you take a look, because we have that. It's outside the male circle, inside the made an auto insurance claim. And then finally, last but not least, outside of both circles, that would be females that did not make an auto insurance claim. That should be 109. And that fills out all our info, and it gives us an idea of cardinality of each set. Okay, so moving forward, let's try and actually have some numbers in there and work the other way around. So how many animals exist in the following set up here, where we have this red S indicating animals that swim, the blue W being animals that walk, and the orange F being animals that fly. Well, all we need to do to find the total number of animals that exist is we add up all these numbers. So we take the 84 plus the 28 plus the 78 plus the 31 plus the 12 plus the 19 plus the 70 and plus the 49. That should be all animals in existence, since all of these are animals inside this square. And that should give us, if we add all that up, we get 371. Now moving forward from there, we can start indicating different sorts of scenarios, like how many animals can swim. If we want to find that cardinality of that set, the swim set, all we need to do is we need to figure out which circle are we looking at. And so what we do is we look and, oh, it's going to be this red circle completely shaded in essentially, and you can kind of see that here. It's going to look like this. And now in this case, what we have is, what are those numbers involved there? Well, we have 84, we have 28, we have the 31 and 12. And if you add all those up, we get 155 is our final answer there. And so now moving forward, let's get to some more complicated questions. So how many animals can walk or fly? So in this case, we have two circles together. So walk or fly. We can do the walk circle, and then we can do the fly circle, and we'll shade those in. So we're going to pull numbers from all of those. Okay. Well, one way we can look at this is we can add them all up. So we can do the 28 plus 78 plus 19 plus 12 plus 31 plus 70. And notice we get 238 at the end of the day. However, there's actually a different way, and this is where things get a little bit more interesting. Venn diagrams can show this. Notice we have 371 animals altogether, so we can take that 371 and subtract off. There's only two parts that are missing, so 371 minus 49 minus 84, you can do that calculation and see that that's also 238. So the Venn diagrams can start to indicate different ways to approach these problems. That's why we like Venn diagrams, if possible, to use them. So last but not least, let's see this just to hit the point home. How many animals can walk and fly? So we need both walk and fly at the same time. And in that case, you'll have that overlap of the F circle and the W circle. And so what does that mean? Well, there's just two numbers, 12 and 19. You add those up, you get 31, and you have your final answer. Okay, so hopefully that makes sense with Venn diagrams. As always, if you ever have any questions, please don't hesitate to contact me. Have a good one.